In this tutorial, we are going to solve question 3, section B for 2024 science paper 1, that is physics. And this question is coming from Simple Pendulum, and the question is saying figure B 3.1 is showing a simple pendulum bulb of mass 200 grams. So whenever you find the mass in grams, you need to convert it to kgs. To convert the mass from grams to kgs, divide that number that you have been given, divide it with 1,000. So using your calculator, what is 200? Before I even finish this question, reading the question, divide it by 1,000. That is going to give you 0.2. So now we are dealing with 0.2 kgs. So now I can continue. Figure B 3.1 is showing a simple pendulum bulb of mass 200 grams, that is 0.2 kgs, swing from position A to E. Now what I want you to understand is that from position A all the way to E back to A, that is one oscillation. That's how we count. Okay, then from position A to C, so from position A to E, it is half oscillation. From position E back to A, again half. So if I do that, it gives me one oscillation. Then from position A to C, that is 1/4 oscillation. From position A to B, that is should be 1/8. Yeah. But what I want you to understand is that to complete one oscillation, you need to go from point A to E, then back to A. So now we can clearly see that the data we have been given here. The next page, I'm going to show you the questions. So the first question is saying, at point B, where is point B? This is point B. Okay. At point B, the pendulum bulb is 120 millimeters away from the ground, and it has got a speed of 0.980 meters. Then they are saying calculate the kinetic energy. So how can we calculate the kinetic energy? Kinetic energy is given by half mass times v squared. So the mass, we say that it is 0.2. We have converted it already in kgs. So the mass should always be in kgs. 0.2. The velocity, which is the speed, is 0.9. We have been told that it's 0.9, but square it. So then let's try to break it down. 1 divided by 2 times 0.2 times 0.9, but this 0.9 you need to square it. So the answer that I'm getting is 0.081. So 0.081 energy, any energy, the SI unit for energy is joules. So the kinetic energy is 0.081 joules. Okay, another one is now telling us to find the potential energy. So potential energy is given by the mass times G times H. H in this case is this one, but we need to convert that one to meters. Now from millimeters to centimeters, it is times, or we divide it by 10. Then again from centimeters, so you can either change it from millimeters to centimeters, then from centimeters to meters. That is okay. So I'll first divide it by 10 to find it, to convert from millimeters to centimeters. That is going to give me 12 centimeters. Again, to convert from centimeters to meters, divide it by 100. So that is going to give me now as my h height to be should be 0.12, like that. Okay, so that is now in meters. Again, if I want to convert that, anything when you're trying to convert something from millimeters to go direct to meters, you divide it by 1000. So you see that this and that will cancel, and you have 12 divided by 100. That is the same as that one, 0.12. So the mass, we already know the mass from the previous here, 0.2. So potential energy is equal to the mass is 0.2. G is always 9.8 times H is now 0.12. So the potential energy will be equal to 0.12 times 9.8 times 0.1. Also I have 0.2, sorry, times 9.8 times 0.12, and I'm getting my potential energy to be 0.2352 joules. But I can round it off because now what I have to look at is this one is in two decimal places, so I can leave it in two decimal places. That is fine. So I can say 0.2, I can say 24 if I want. Since this one I've left it in three decimal places, let's also leave it in three decimal places. 35 joules. So the gravitational potential energy is 0.235 joules. That's the answer. Then now when I do that, one thing I need to understand is that I'm going to now go to part C. Is asking me to find the internal energy of the bulb. Internal energy is basically the energy that we have, the total energy that we have in the system. So in this case, the internal energy is basically potential energy plus kinetic energy. So potential energy is 0.235 plus kinetic energy is 0.81. So if we add this, what are we going to get? So 0.0, this is 0.08, 0.081. Okay, so 0.081, 0.081 plus 0.235. So the answer I'm getting now as the total is 0.316 joules. That is my internal energy. So basically these are the answers for this question. So just try to understand simple principles, try to explore different questions, and try to apply the same concept. I believe this is going to be helpful for you. Okay.